All right, hey everyone, ready for another deep dive? This time we're going to tackle some physics.
Oh, fun.
Yeah, specifically how things move. Like when gravity's the only thing acting on them.
Oh, like free fall.
Exactly. And to help us out, we've got this super cool educational website from Singapore. It's got simulations, lessons, all kinds of stuff to make it really clear.
Yeah, I was looking at that. It's got some really neat visual.
Oh, for sure. Like if you've ever wondered how long it takes for something to fall from, say, a skyscraper,
Yeah.
well, by the end of this deep dive, you'll be able to figure that out.
Awesome. I'm already intrigued.
So the first thing this website jumps into is kinematics.
Okay.
Honestly, that word always kind of sounds intimidating to me.
Yeah, I can see that. It sounds kind of, I don't know, jargony.
Right. But it's actually not that complicated. What would you say is the simplest way to explain it?
Kinematics is really just the study of motion, like how things move, but without getting into why they're moving.
So it's not about forces or anything like that?
Not really. It's more like, okay, this thing is moving this fast in this direction and using math to describe that.
So instead of asking, why is that ball rolling,
Right.
kinematics is more like, how fast is it rolling and in what direction?
Exactly. It's all about describing the movement itself.
And what I like about this website is that they use these simulations so you can actually see it happening.
Right. It really brings those descriptions to life.
Speaking of different kinds of motion, the website talks about a few main types. Can you remind me what those are?
Sure. Well, the most basic one is being at rest, just not moving at all.
Right, I said.
Then
Yeah.
you've got uniform velocity. That's basically like cruising along at a steady speed
Okay.
in a straight line. Yeah. So no speeding up, no slowing down, no turning.
Like driving on cruise control on a perfectly straight highway.
Perfect analogy.
Mm-hmm.
Then there's non-uniform velocity. That's where things get a bit more interesting.
Because that's where acceleration comes in,
You
right?
got it. Speeding up, slowing down, changing direction, all that falls under non-uniform velocity.
And the simulations on this website show acceleration in action, which is really helpful.
It definitely makes it easier to visualize than just, thinking about it abstractly.
Okay, so let's get to the main event. Free fall. Everyone knows what it means when something falls, but in physics, it's a bit more specific, isn't it?
Yeah, free fall in physics means we're talking about an object falling with gravity as the only force acting on it.
So, like, no air resistance or anything like that?
Precisely. Think of an object falling in a vacuum. That's true free fall.
And that's where that whole heavy objects fall faster myth gets busted, right?
Exactly. In a vacuum, a feather and a bowling ball would fall at the exact same rate.
Whoa, really?
Yeah, it's because of this thing called acceleration due to gravity, which is often shortened to just g.
Gee, that rings a bell from my physics days. But to be honest, I'm a little fuzzy on what it actually means.
Well, g basically measures how much gravity speeds things up as they fall.
Okay.
Here on Earth, g is roughly 10 meters per second squared.
Meters per second squared. See, that's where I start to lose it.
I hear ya. But think of it this way. Every second an object falls, its speed increases by about 10 meters per second.
Okay, so after 1 second, it's going 10 meters.
Yeah.
After 2 seconds, it's 20 meters and so on.
Exactly. It doesn't matter how heavy the object is, as long as it's in free fall, it speeds up at that same rate.
That's pretty mind-blowing. But hold on, what about air resistance? That obviously affects things when they fall in the real world, right?
Oh, absolutely. Air resistance is a force that pushes back against anything moving through the air.
So the faster something falls, the stronger the air resistance.
Exactly. And that's why, say, a feather falls so slowly compared to a bowling ball.
Because the feather's affected by air resistance way more.
Right. It has a much larger surface area compared to its weight, so the air really pushes back on it.
That makes sense. And that brings us to something called terminal velocity, right?
You're on the track.
I've heard of terminal velocity, but I gotta admit, I'm a little hazy on the details.
Well, it's actually pretty intuitive. As an object falls, the air resistance keeps increasing until, at some point, it gets so strong that it balances out the force of gravity. So the object stops accelerating, even though it's still falling.
Whoa, so it reaches like a max speed?
Exactly, that's its terminal velocity.
Oh, okay, I get it.
Think of a skydiver. They don't just keep speeding up forever. At some point, the air resistance pushing back is as strong as gravity pulling down.
That's a really cool way to visualize it.
Right. And the cool thing is, on this website, they have these simulations where you can adjust the amount of air resistance and see how it affects terminal velocity.
Oh, that's awesome. So you can like make it super realistic or almost like a vacuum.
Yep. You can really see how those different conditions change how things fall.
You know, it's funny. I remember in physics class, there were always those, like, misconceptions about motion,
Oh, yeah, for sure.
like the heavier objects falling faster thing. We already talked about that. But I wonder why those misconceptions stick around,
Yeah.
even when the physics is pretty clear.
I think it's because our everyday experiences can be a little misleading.
Yeah, like we see a feather falling slowly and just assume that's how it always works.
Right. But we have to remember that in those cases, air resistance is playing a huge role. If you took air resistance out of the equation, the feather and a bowling ball would fall at the same rate.
It's like our brains kind of take a shortcut.
Yeah, it's easy to forget about all the other forces that are usually at play.
That makes sense. But then that makes me think about another misconception. Like, people think you need a constant force to keep an object moving at a constant speed.
Yeah, that's a classic one.
But like, if you were in space and threw a baseball, wouldn't it just keep going forever in a straight line?
Yep, you got it. If there's no friction or any other force acting on it, an object in motion will stay in motion at a constant velocity.
It's like Newton's first law or something, right?
Exactly. That's one of the fundamental laws of physics.
So why do things eventually stop here on Earth? Like, if I roll a ball, it doesn't just keep rolling forever.
Well, that's because on Earth, there's almost always some kind of force acting on the object. Friction, air resistance, gravity jitter, those all work to slow things down or change their direction.
Oh, so it's not that objects just naturally want to stop moving.
Right. It's that those external forces are acting on them.
That's really interesting. It's like understanding these basic principles helps you see the world differently.
Yeah, for sure. It's like you're suddenly aware of all these invisible forces that are always at work.
And speaking of seeing things differently, remember that question we asked at the beginning
Yeah.
about how long it takes for something to fall from a certain height?
Oh, yeah.
Well, now we can actually figure that out.
You bet. Using the concepts of free fall and acceleration due to gravity, we can actually calculate how long it would take for an object to fall from any given height.
Whoa, for real? So we could, like, figure out how long it takes for a penny to fall from the top of the Empire State Building.
Exactly. Of course, in the real world, you'd have to account for things like air resistance, but those core principles give us a pretty good starting point.
That's amazing. So does that mean, like, if we went to the moon, things would fall slower?
Yep. The moon's gravity is weaker than Earth's, so G is different there.
So a penny would take longer to fall from the same height on the moon.
Exactly. It would be really cool to see, actually.
I can't believe how much we've learned just from looking at this one website.
It's pretty amazing, right?
It really is. Like,
Yeah.
it makes you realize that the same laws of physics are at work everywhere in the universe, just with different specifics.
Yeah, that's one of the things that's so fascinating about physics. It's like this universal language that describes how everything works.
I feel like we've unlocked a whole new way of looking at the world.
I know what you mean.
And this website does such a great job of making it accessible with those simulations and all the real-world examples.
Yeah, it really helps to connect the dots between the theory and what we actually observe.
Okay, just to sum things up for everyone listening, we've covered a lot of ground today. We started with kinematics, the study of motion, without getting into the forces behind it.
Right, it's all about describing how things move, not necessarily why.
Then we dove into free fall, where gravity is the star of the show.
We talked about acceleration due to gravity, or G, which is how much gravity speeds things up as they fall.
Busted that myth
Yeah.
that heavier objects fall faster in a vacuum, at least.
Right, it's all about that constant acceleration, regardless of mass.
We also looked at air resistance and how it can lead to terminal velocity. It's that point where a falling object reaches its maximum speed because air resistance balances out gravity.
And we even talked about how these principles apply on other planets, where the value of G can be totally different.
This has been such an incredible journey. I feel like I have a whole new understanding of the physics at work in everyday life.
That's fantastic to hear. That's what we hope for with these deep dives, to spark that curiosity and help people see the world with fresh eyes.
Well, mission accomplished. Thank you so much for taking me on this amazing tour of motion and gravity.
My pleasure. It's always fun to explore these topics with someone who's eager to learn.
And a big thank you to the creators of this incredible website. It's seriously changed the way I think about physics.
Agreed. They've done an amazing job of making these complex concepts engaging and understandable.
All right, everyone. That's all for our deep dive today. We'll put a link to the website in the show notes so you can check it out yourselves.
Yeah, definitely explore it. You'll be surprised by how much you can learn.
Until next time, keep those brains buzzing. And as always, thanks for joining us. It's like we've I don't know, cracked the code of the universe or something.
Oh, in a way, yeah. Physics is all about understanding those fundamental rules.
And this website, it really does a fantastic job of making those rules understandable.
Totally. Those interactive simulations are amazing. It's one thing to just, hear about terminal velocity,
Right.
but to actually see it happening, that makes a huge difference.
Oh, for sure. And the way they connect it back to real-world stuff, like the skydiver example,
Those connections are key.
it really makes it all click into place. So just to kind of recap everything we've talked about today,
Yeah, good idea.
we started with kinematics, which, remember, is all about how objects move without worrying about the forces involved.
Exactly, just describing that motion.
Then we got into freefall, where gravity takes over.
Right, talking about acceleration due to gravity, that G thing.
And we busted that myth about heavier objects falling faster. Well, at least in a vacuum.
Exactly, that constant acceleration. It's the key.
We also explored air resistance and how it leads to terminal velocity. That maximum speed a falling object reaches.
Right, because the air resistance balances out the force of gravity.
And we even touched on how all this applies on other planets, where gravity can be way different.
Yeah, different G, different falling speeds. It's pretty wild.
This has honestly been such an incredible deep dive. I feel like I have a whole new appreciation for, like, the physics of everyday life.
That's awesome. It's amazing how much physics is happening all around us all the time.
It really is. Well, thank you so much for walking me through all this. I've learned so much.
It's been my pleasure. And hey, to everyone listening out there, keep those brains curious. Keep asking those why questions.
Exactly. And if you want to explore those questions even further, we'll put a link to the website in the show notes.
Definitely check it out. Those simulations are super fun, even if you're not, like, a physics whiz.
All right, that's going to do it for us today. Thanks for joining us on this deep dive.
See you next time.
And until then, keep exploring the world around you.